allow me to do it in here, otherwise I'm gonna, yeah. But as my wonderful introducee said, my name is Elliot Roth. I am a self-proclaimed startup junkie and biotech hacker. Now, a lot of you are like, oh, what does that mean? That means I'm the young upstart here to do jumping jacks, excite you and amaze you about the potential for biology to absolutely transform the way we do things and interact with building materials, with the way we go about living, with all sorts of different things. And I do that in a number of different ways, but when I was asked to come to 1 Million Cups, I had to hone in and decide which one of the different projects that I'm involved in do I really want to emphasize, do I really want to showcase to the people all around here. And that was ViV, which is a design firm focused on using mycelium, which is a structural compound in mushrooms, to create building materials. So, who am I? I do a lot of stuff, as I said before. This is a lot of my stuff. Now, I'm really into the intersection between different disciplines. And one of the things I really enjoy doing is creating communities that serve as tools for entrepreneurial opportunity. Whether that's through helping out with a DIY science lab and starting that space up, spinning up a student product entrepreneurship group, or building a new kind of building material that can be used as a construction device. All of those kind of serve as interesting, cool opportunities for people to start their own projects, start their own ideas, and get those wheels spinning. I was talking to somebody, Scott, actually, and one of the things that we realized a little bit was that we do things as a means to really do what we love, right? We start companies, we go about the different things that we do. And so what I really enjoy doing is just meeting and talking. Like that's most of my job, right? So as a means to meet and talk to interesting people, I love getting involved with all of these communities in different ways. So I'm here today to talk to you guys about a problem. And the problem that really occurs is looking around and realizing what we're doing to impact the environment, right? And like, oh, this guy with the spiel about the environment, I hear it all day. And like, God, just let me drive my Hummer down the street 2 blocks and pick up my packaged goods, bring it back home and throw away everything, right? Like, who is this guy up here? But really, if we change our thought process, if we shift it a little bit, you can really realize that there are all sorts of renewable materials and other things around you. There's this biological potential that you can really tap into in order to grow things. So, I have a question to ask all of you, right? How many of you have ever tripped over the sidewalks in Richmond? Right? Most everyone here.
You mean just today, right?
just this morning.
Okay.
Just this morning. So I have a doozy of a story. Now this may get very graphic. So this was me.
Oh,
Ouch. This was me 2 years ago, where I went for a bike ride and I hit a rough patch of pavement going down the street, flipped over my bike handlebars and broke my face, literally, right? And that kind of moment normally would be like a finisher. Luckily, I was okay, right? I got like a good dentist on call and other things like that, so I got fixed up for my winning smile, of course. And what eventually happened with this is I realized that this was a huge problem that really needed to change. So, as you guys know, construction happens in Richmond every day. All the time, blocking your commute to work, other things like that. And it's because the materials we use degrade so quickly, right? I realized through walking around Richmond after my accident, just thinking about things, that all the different materials in the environment aren't meant to exist in there, right? And one of the main reasons that I flipped over my bike handlebars is that I hit a root that was growing out of the pavement. And it was because of the fact that biology, nature, was in direct conflict with our civilization, with the way we go about working in cities. And so I was thinking, I just kept on thinking, and I was, how do we combat this direct conflict? How do we make it so that it's more interwoven, intermingled, and that we can tap into the biological functions of nature in order to build things for our cities. I mean, we already do it, right? What are we standing on, right? We're standing on wood. Wood is a natural biological function that we've tapped into. It is the original building material. We've taken wood and we've purposed it to build giant, massive structures in different kind of ways. So why not do that for mushrooms, right? So this is where the idea gets a little crazy. Everybody's like, mushrooms, what? So when I told my parents after graduation that my plans were to grow mushrooms in my basement, they thought it was crazy. They were like, you're coming back home now. We don't want you to get arrested. What are you doing? And so what ended up happening, though, is I convinced them, right? So mushrooms are an incredible, incredible organism. What they do is they grow on waste products of other organisms. And so they can take all the trash, disposables we were talking about, they grow on virtually anything. You can put them in a radioactive environment, you can put them in virtually no air, water, and they'll still grow. Fantastic, right? And what's amazing about them is that they're made of the same polymer found in crab shells, in lobster exoskeletons, and in bug exoskeletons as well. So incredibly solid, incredibly durable, and they last a long time. In fact, it's the second most common polymer in nature, yet we hardly ever use it for anything, which is kind of ridiculous when you think about it. So, one of the things that we're doing with this product, which I just passed around to you, that was grown out of mushrooms, right? And so you guys can check it out, you can keep on passing it around. Yes, okay, so the actual building material that it's on, it grows on cellulose, which is like cast off corn stalks, fiber, resin, lignin, paper byproducts, things like that. But it's all waste streams, right? And so when we were going around, we were thinking, well, who will really buy this? We came up with the concept of architecture firms, landscape designers, and other such things, because they're looking for an alternate building material. We haven't really had something different since steel, really, when you think about it, in terms of building buildings. In fact, we're still using worse techniques to make concrete than the Romans were using, which is absolutely ridiculous. And the construction industry comprises 40% of all the world's resources, right? It takes up all of the concrete, asphalt, bricks, ceramics, other such nonsense, wood, that the world uses in order to grow and expand. So, what's incredible about using mycelium for this function is that it serves as a platform technique, right? You can use it in virtually any application you can think of in terms of building materials because it's incredibly structurally sound. It's very, very similar in nature to ceramics, and it can serve as a replacement for any of these. Now, when considering all these markets, what we really had to think of was, will somebody let us grow mushrooms on their street? And the answer, most of the time, instead of like, unless you run into like a hippy-dippy neighborhood or other things like that, was no. Most people are like, mushrooms, ew, what's that? Right? And so just replacing our current streets with mycelium, with mushroom, isn't gonna fly. So what we started thinking about was the different surfaces that cover a city and what we can really tap into. What we came up with was this. This is an asphalt roof, right? This is the nastiest, most polluting thing. It's really, really bad. It doesn't last. The main reason that we use asphalt in cities is it's cheap, and it's quick, and it's dirty, right? So the vast majority of roofs have this asphalt. It's a good 97% of all roofs are covered in asphalt shingles. Now these shingles only have a lifespan of about 15 years or so. What's incredible about this entire thing is that the same asphalt that we're using as a waste product of the oil industry, which is already polluting things, this is the crude oil at the very bottom of the barrel that they then turn into this asphalt, which leaches harmful chemicals into our water supply. So water runoff hits our roofs, runs off, carries away all the oil, dirt, heavy metal particles in here, goes directly in our water supply, and it's probably in the coffee. Sorry. Don't mean to make you put it down. But there's an alternate, right? If we use mycelium, which actually captures harmful metals from the environment and incorporates them into its structure. It's got very similar properties to roofing shingles, right? If you make it bioinert and deactivate the actual mushroom in there, you can have it last for a prolonged period of time, and it can serve as a very, very viable replacement for roofing shingles. So these are the current different roofing shingles out there. Now, the real key is to get mycelium right about there, right? So currently, 97% is asphalt shingles. Now the main difficulty with this is that it's made out of oil, right? It burns. So what happens when your house is on fire? Your roof is the fuel for that fire. Now mycelium, because it's a biopolymer, what happens is it actually extinguishes itself. It's self-extinguishing. It's got the same kind of structural integrity as asphalt, and it lasts a prolonged period of time if you inactivate it. So this is where we're currently at, right? We got a small VCR grant in order to do this. Thank you, VCR. We have a couple of prospective funding dollars, and we're working on small-scale clients. So one of the things we're doing as an experimental survey into the growth process is we're 3D scanning people's heads and then creating mycelium busts of people. So growing out mushroom as a 3D sculpture of you. So if you guys are interested in one of those things, definitely talk to me about it. That's one of the things we're doing in order to start our exploratory research process. So we're still very much early stage, but this capital investment is what we're looking at as a means to start turning this into a product that companies can use. Now, since this is a biologically grown material rather than processed, what's great is that you can actually hit it in the growth process, where it takes 3 weeks from start to completion. You can grow it in any kind of form, shape, mold, whatever it might be, and then chop it up, send it out, and it's exactly like asphalt, ceramic, tile, whatever it might be. It all depends on the initial substrate behind it, whatever it grows upon. The mushroom takes the properties of whatever it grows upon and starts utilizing these properties. So those properties are harder, more dense, lightweight. You can make these floating mycelium foam blocks. You can do all sorts of different things with it. It's an amazing, amazing material. So this is where we're currently at. We're working out of ViV Lab, which I do believe is on the docket to be talked about later on in one of the main cups, so don't miss that. It's a nonprofit science laboratory that we're utilizing the space because it's an IP-free zone. One of the things that we had to do is start our company outside of the university, because the university would take all the different intellectual property. So I'm a huge advocate for students, for faculty, graduate students, for starting science-driven, technology-based companies, but the main difficulty is there is this barrier to entry, right? A lot of people don't think that they can go about attempting something crazy like growing mushrooms. But really, it's dirt simple. I mean, how many of you have grown mold on bread when you leave it out too much? Right? Same kind of concept. We want to lower the barrier to entry to people realizing that they can start growing the same material, open source it, make it so that everyone, anywhere, can start experimenting with biology and tapping into those kind of things, so that things like happened to me, where I broke my face, don't happen to anybody anymore. So this is the potential market for just asphalt roofing shingles. That's it. That's just this, right? In terms of thinking of a scalable company, in terms of thinking of something that's a huge benefit to the Richmond area, Richmond's extremely well connected with all kinds of different architecture firms, with all kinds of different construction firms, and real estate companies. So if we get into this market, if you guys help me help Richmond grow this huge slice of the pie just for asphalt roofing shingles, not for the myriad of other potential applications, can be brought here. So that's ViV in a nutshell. That's just a small segment of what I've been doing, experimenting with a bunch of different things around the city, building in different communities, and I hope we can work together to make this idea a reality. Thank you so much.